My name is Mohammed Said, and my these are my team members: Tufail, Ahmed, and Shehbaz, and Abdul Subhan. So the topic we have assigned for the IBM project is bias detection and mitigation using AI models. So, bias detection and mitigation is about making an AI model fair and accurate. When we train an AI model, the data we use might have hidden biases. So, this means if the data is biased, the model can also become biased and make a wrong decision. So, bias decision means identifying what kind of bias is present in the data. For example, if there is a less data about a particular gender, like age, group, like region, or any other kind of things, the model might make a wrong prediction about those groups. So we check if the data is unbalanced or biased in any ways. So bias mitigation means fixing the bias. We find the data. This could be involves like balancing the data or changing certain features or using special techniques to ensure the model is fair to everyone. So overall, this process ensures that the AI model is fair to all groups and does not make biased decision. So this is how we do the projects, and we have developed IPY and means Google Colab Notebook where we develop this model, and on the basis of some data set we use a credit score data set, and we will discuss why we use credit score database data set. That thing comes here is we are using here the credit score data set. Why we are using the credit score data set in this is because using a credit score data set in our project is like help to detect and fix bias in AI models that makes long decision. Since credit score can be influenced by factors like genders or income, so our project can ensure that the model treats everyone fairly and does not make biased decision. So this is important for improving our fairness in financial systems and ensuring that everyone has a equal access to the loan and financial service. So this is a thing why we use a credit score data set. We are basically dealing with a credit score data set to check if the model fair to everyone, especially based on gender and material status. Our goal is to see the model is predicted credit score equally well for all the groups. Like example, male was female and married was single. So these are the things. We will check performance using the F1 scores for each group. If we find unfairness like bias, we will reduce it using the methods like more SMOT, which will create an extra data for a small groups to balance the data set, giving more importance to the unrepresented groups. LFR, like changing the data in a way that reduce bias, both still predict well. Okay, so these are the things we can do. So as we go down, we have loaded the libraries and installed the libraries and uploaded our data set. Next, we have done some extraction and saw some data exploration things and future extractions. So we gone through the data using the libraries, and we have seen like the credit score. We came across the credit score, and as we go down we have done here class like class distribution analysis. In this part I have done we checked how many records belong to each credit score category, like high 130 113. Okay, it's 113 instance average, like 36 instance low and 15 instance. We notice that most people have a high credit score and very few have a low credit score. This is called imbalance. Means which can cause the model to predict high more often and ignore the low cases. That's why we need to fix this imbalance to make sure that the model fair and accurate for all the groups. So as we go down, we our next part is we have just imported C1, and okay. After that, we have done the data pre-processing and model evolution. So we come across this. We have done a data preprocessing and model evolution, where you can see we have done encoded categorical features in which we convert a category like gender, educations, and material status, exam, etc. These are the things into a number so that the model can understand them. So the target variables are like which separate our futures input and target variables like output, which is a credit score, and we applied a smooth. Why? Because since our classes are like high, average, and low credit score are imbalanced. So we use smooth to create a synthetic data for the unrepresented classes, helping the model to learn better. And we have done standard futurization, uh, we make sure all the features like age, income, and etc. are all on a same scale. Okay, we have seen this part. Then the next part we have done is like model comparison and AI fairness. Okay, so here the baseline model, like dummy classifiers, this model just predict the most common classes, like always saying high credit score. It's not very accurate. It's about 28%, as it is a baseline model. So then we use a logistical regression. This model performs much better with an accuracy of like 98%. We showing that approach we have done is very well. So then we have used like XGB classifier model. So this model also does great with an accuracy of 97%. So till here we have done this progress. Then after this, the next part comes is this. Okay, the next part has been contributed by my friend, my team member Shaibas. So he will next guide us what he has contributed to this project through his approach. Okay, Shaibas, you can continue.
Now, before dividing into AI fairness analysis, we examine the class distribution for the gender column. This helps us understand the representation of different groups in the data set. Gender-based model performance evaluation. Split the data by gender. We divide the data into two groups, one for male and one for females. Define features and target for each group. For each gender group, we select the features and target variables separately. Apply SMOD to balance the data to fix any imbalance in the data. For example, if one gender has favors sample, we use SMOD to create more balanced data for each group. Standardized feature, we make sure the feature for both groups are standardized, scaled equally to ensure fairness. Evaluate Evaluate performance using cross validation. We test the model's performance separately for each gender group and compare the results to see if the model performs equally well for both genders. Result for random forest classifiers. Male group accuracy 100% for all folds, mean accuracy 1.0, perfect performance. Female group accuracy varies slightly, with score ranging from 94% to 97%, men accuracy 97.0.1%. Result for logistic regression. Male group accuracy varies between 91% and 100%. Mean accuracy 97.39%. Female group accuracy varies between 94% and 100%. Mean accuracy 97.02%. Conclusion. Although accuracy differences between the male and female group are small, the male group achieves perfect accuracy while the female group accuracy is slightly lower. This suggests potential bias favoring the male category, which emphasizes the need to address and mitigate such biases to ensure fairness in the AI model. We evaluate the model performance for male and female using three important measures: accuracy, F1 score, and the confusion matrix. Steps: create evaluation function. We make a function that calculates or shows the accuracy, F1 score, and confusion matrix for the model, making sure the data is the right format. Evaluate for male group. We use this function to check how well the random forest classifiers and logistic regression model perform for the male group. In this section, we calculate bias metrics. Metric to access how well the logistic regression model performs across different gender groups. Define bias metrics calculation. We create a function to calculate the bias metrics, which evaluate the model's overall accuracy and F1 score, and then break it down by gender, males and females. Using this function, we calculate the bias matrix specifically for the gender attribute to see if the model performance is uniquely between males and females. The goal is to measure any bias and ensure fairness in the model's prediction across different groups. Result for bias matrix calculation: overall model performance accuracy 68.9%, F1 score 56.2%, group wise metric. Female of 0 accuracy is 65.1%, F1 score 51.4%, males accuracy is 73.1%, F1 score 61.7%, bias score. Accuracy differences: 7.96% higher for males, F1 score differences 10.35% higher for males. Accuracy ratio is 0.89 male. The results show a slight bias in favor of males, as their accuracy and F1 scores are higher than those for females. Although the differences are not huge, they highlight the need for continuous monitoring and addressing biases to ensure fairness in AI models. This analysis was focused on the logistic regression model, which performed similarly to the other models used in the study. Now, further will explain by my friend Abdul Suban Patel.
we we will create two bar chart to compare the accuracy and the F1 score for the male and the female. The accuracy chart, the one bar for the male is 73.1 percentage, and the one for the female is 65.1 percentage. It shows how well the model perform for the each gender. The F1 score chart, the another bar for the male is 61.7 percentage, and the one for the female is 51.4 percentage. This shows how the balance the models perform for these for each gender. For the material status, the attribute will evaluate the Bayes matrix in the same way as we did for the gender. Here, the class distributed for the material status. Here, the marriage is 0 and 87 instead of single one. The 77 instance will now calculate the accuracy and the F1 score for the both the marriage and the single group. Using the logistic regression model, these matrix will allow us to understand if there is an bias between the two groups. The Here's the result shows the significant bias in the favor of the marriage category with such higher accuracy and the F1 score for the marriage group compared to the single group. These include substantial disparity in the model performed based on the material stage, highlighted the necessity to the addressing and mitigating such as bias. Utilizing from the material status column to further illustration, these findings will utilize the bias matrix for the material status attribute. The further part will be continued by the to fail.
So, hello, sir. The further part will be continued by me, Tufail Ahmed. So, the encoded categorical features convert the features like gender and martial status into the number for the model. Define features and target. To set up your own data, we have utilized the credit score is that the target we want to predict. Calculate the simple weights. We have calculated for each group based on the gender and martial status to balance out any bias in the data. Group with favor sample get higher weights. Combine weights. We combine the sample weights from gender and martial status to get one overall weight for each data point. Applying smooth, since our classes are imbalanced, we use smooth to create a synthetic sample balancing the data, adjusting the weights for smooth. After generating synthetic data, we adjust the sample weights to make sure that they match the original data distribution. Standardize the features. We have a standardized scalar to standardize the data so each function contributes equally. Also, we have utilized the k-fold cross-validation with sample weights. We perform the k-fold cross-validation where the data is split into 5 parts. The model is trained on 4 parts and tested on the remaining parts. We included sample weights during training to ensure fairness. The results of the model are shown as cross-validation accuracy. The model's accuracy scores for different folds are 1.0, 0.98, and 0.956. These are the mean accuracy, which is 0.979. This demonstrates that the model performance will across different parts of the data. Baseline model dummy classifiers. So further, the baseline model, which always predict the most frequent class, has the so in this section, we are using learning fair representation to reduce the bias in the database based on gender and martial status. Database preparation. We focus on gender and martial status as the sensitive attributes. We split the data into 70% training and 30% testing data. LFR transformation. We have applied LFR to reduce the bias, adjust some parameters to get back best results. Model training and evaluation. We trained a random forest on the transform date and evaluate it using accuracy and F1 score. So these are the code for that. Also, the results. Gender accuracy 1.0 F1 score. Gender accuracy is 1.0. F1 score is 1.0. Martial status accuracy is 1.0. F1 score is also 1.0. Using learning fair representation, eliminating bias in the datasets, leading the perfect accuracy and fairness in prediction for both gender and martial status. Fairness matrices analysis. Gender. Disparate impact 0.4213 shows unfair treatment between male and female groups. Statistical parity difference 0 - 0.4006. Females are less likely to get favorable outcome than males. Martial status. So despite impact 0.3626 indicates unfair between married single group. Fairness for gender. Despite disparate impact, 0.421 shows unfair treatment between men and women. Statistically, parity difference is also women are less likely to get affordable result than men. Fairness for the martial status. So the gap is smaller now. In short, gender bias is still noticeable, while martial status bias has decreased. So these are the benchmark results which we have came across. The final part of the coding will be concluded by my friend Sahil Sheikh. Okay, over to you, Sahil.
As we came across the team contribution, we have seen many things like cleaning of a data, preparation of data, and all the contribution part like model training and all we have done as so far. So at the end, the conclusion comes like after training the model on the splitting the data and LSR, all these things after applying the things, we came to a conclusion and we finalized the model. So after doing this, here we have done a processing like splitting our data and training and testing set parts, like balance the data like using smooth and fixing the class imbalance, like scaling the future. So they are all on the same scale. So this is the model training part what we have done so far. So after training on the random forest model on a balance and scale data, we have saved and loaded the model. Okay. So as you can see on the code, saved and we have saved and trained the model to a file like credit score model.pkl and loaded later for prediction part. So we can use the model and get predicted. So as far we have done this much, and after that we have used the model to predict a new credit score based on an input, like example like age, income, on base of the futures what we have trained from the start. The model will predict if a credit score is good or poor based on the new input. So this will be a bias thing which we have done so far. The this will give an output of this part. So still we have done so far this much. And the team contribution, if we say the team contribution is like I personally have done all the collab part of the system, and like solving the error and all the we have used representative ais to get a robust solution like ai like chat gpt, like other all the ai models for better robust solution. If you get some if you stuck anywhere, we have used some ai tools as well as we have used some guidance for others. We came to this finalized output. The further things like the tools and all the resource gathering has been done by our team member Shaiba Sheikh, and all the framework part like documentation part and the representation part, all this structure has been done by Subhan Abdul Subhan, and the final touch up to cloud will be held by our team member to fail. So this is the final solution we came across. So thank you so much.